Let's take an example of bounding the risk. We have some work that's being done in the spring, and we're concerned about severe rains. We know that there may be some rework required if the work is damaged by water. Water removal, of course. This causes delays to the schedule, some additional costs. Some extra work is required, some extra labor is required on the job to actually perform the water removal. And we have some more uncertainty than one issue should merit. So let's bound the risk. We start by identifying the best outcome. The water damage is significant, but it is recognized as additional scope. We have full compensation for the extra work required, and the only disadvantage that we can think of is that the client is paying some extra and is unhappy about the additional funds required. Then let's move to the worst possible outcome. The water damage is more significant than our budget expected. However, it is not recognized as outside the normal scope of events. The rework and water removal is required at our own cost. The client is very happy, but of course the disadvantage is our costs have increased and the job is much less profitable. What is the most likely outcome? Now that we have the best and the worst identified, this is easier to formulate. The most likely outcome is that there is water damage, some rework and water removal is required and is not significant enough to claim as extras. We're operating within our contingencies and within the normal course of events. Our margins are somewhat reduced, but we are still profitable. So having bound the risk and identified the possibilities of events, let's put some numbers and some probabilities to them. The probability of sufficient rain for water damage, well, let's say that there's 60% yes and 40% no, it's happening in the spring. So the fact that it will occur has to be split between the best possible outcome, the worst possible outcome, and the most likely. And the most likely we're going to consider it at, we'll give it 30%, the worst at 15%, and the best also at 15%. So now we can see that even though we have some serious concerns about the worst possible impact, its probability is only 15%. When we're calculating expected cost of this risk, of this worst possible outcome, it will be quite low because, of course, the probability is low. Also, with the best possible outcome, unfortunately, also has this low probability, and the expected value of that best possible outcome is also low. And of course, the most likely outcome is mitigated by the two, the best and worst possible outcome. When we complete the risk analysis of these potential outcomes, we can look at the expected delay of both the best outcomes, the worst case outcomes, and the most likely. And we add those up when we see that we should probably have at least a day and a half as a contingency in our schedule, some float added to our schedule to cover this set of risks, all three, the best possible and most likely outcome. Also, when we look at our expected cost, we can see that we probably need about $4,000 in our contingencies to cover the worst case outcome. The most likely outcome, expected cost, is roughly $1,000 based on our estimates. And our best case outcome is also a positive outcome of roughly $1,000. So in the end, we're really covering the worst possible outcome. This will impact the calculation of our contingencies and will give us a much more realistic number to work with in developing those reserves. The software that I'm using to create the various clips and to lead us through this process of bounding the risk, including calculating the probabilities and the likelihood of outcome, is RiskMP. RiskMP is a specialized software application that will guide you through the creation of a full risk management plan. In conclusion, bounding the risk is a simple and structured methodology to develop a realistic analysis of a particular risk. Thank you for participating in today's presentation of Bounding the Risk. Please join us for other topics in risk management planning.